All right, so one of the things that I forgot to mention here is that I also teach, you mentioned the master's program. I teach the master's program over at UAH. I teach the 401, the 501 class over there. And you know, I met with Dr. St. John, Karen St. John, who's the dean for the College of Business Administration. And a lot of people were coming through the continuing professional studies classes to take the hands-on stuff because they weren't getting it over in whatever college that they were taking it, taking the regular undergraduate or graduate degrees. But what we've done is we've helped to stand up this interdisciplinary degree now. And you can have different tracks, whether it's computer engineering or through the College of Business Administration, where now we offer the master's degree in cybersecurity. It used to be the NSA approved information assurance degree, but now they've actually changed the name to master's degree in cybersecurity. So, you know, taking some of the things that I've learned as a certified ethical hacker, featured instructor, and an EC Council instructor, as well as you know, some of my master's curriculum at NYU Polytechnic School of Engineering. I bring in a lot of the overview or survey of information assurance. So that's just my lame pitch at trying to get people into the master's program. I typically will do a lot of the hands-on things over there based in a lab environment. So I would encourage you to take that class over there. So the first domain that we're going to actually get into here is this network security and telecommunications. And if you want to follow along in your hymnals with me here, this is going to be the first one that we have. And this is a bear right here. This is the you know, per space in the actual book that Sean Harris gives us. This is the biggest domain. This has got the most girth. If you look at it, I want to say that it's close to 300 pages in the book, and somebody could correct me on that. But what it does is it goes through some of these things that you probably have learned in the past. And really it gets into the OSI model, talks about some of the different networking technologies, gets into cabling, as cool or as lame as that may seem, and it also talks about some of the devices. So when we start to get in and talk about some of these, there are some differences between the OSI and the TCP IP models, but the important thing for us to look at is here with the OSI model. And it's kind of funny because how many times have you guys been in your meetings and somebody has mentioned something about a layer 3 device or a layer 4 device? Has anybody ever been in a meeting where somebody said that before? Okay. Well, if you have it, then you're in luck because you're going to learn the OSI model. And what does the OSI stand for? Open Systems Interconnectivity, or interconnections. You know, ISO, which is kind of funny, it's backwards. The International Standards Organization, not to be confused with the Open Systems Interconnectivity, OSI, ISO. So ISO always, you know, puts out these great things that allow us to have standards and the ability to internationally use a standard in a way that somebody over in China, over in India, or right here in the good old USA can use. This is important because this is really the foundation that if you have already learned this and forgotten it, there's a good chance that you're going to see some questions talking about layer 3 or layer 6 or layer 1 in the exam. Okay? And an easy way to remember this, and I'm going to go around the room and see if somebody else has a way to remember this, but a mnemonic way is all people seem to need data processing. Starting up at layer 7, going down to layer 1, all people seem to need data processing. Repiten, por favor. Say it back to me. Ready? All people seem to need data processing. One more time. All people seem to need data processing. So, as silly as this may sound, you know, if I'm in a meeting with somebody and somebody says something about, you know, a layer 4 transmission isn't getting communicated properly, I immediately in my head think, and I count it out. I'm like, okay, well, layer 4, and I don't actually use my fingers, right? But in your head, in that lickety split, you know, way that you guys, whatever way you do that, you can think to yourself that, hey, layer 4 is the transport layer. And an easy way to remember that is all people seem to need data processing. Okay? All people seem to need data processing. And this is super important. And we'll decompose each one of these. So the application layer, presentation layer, session layer, transport layer, network layer, and physical layer all help us in a way that's standard and allows us to communicate from point A to point B. So how does it do it? Well, this is typically what you see whenever somebody asks you to talk about encapsulation. So if I was, you know, taking a note here, I would say encapsulation, decapsulation. So let's just say Lonnie and I want to actually talk using the OSI reference model. Well, how are we going to do that? Well, if he was using Novell and I'm using Microsoft, there has to be some way that it can translate that from IP to IPX, right? So we need some sort of translation layer in there in order for that magic to happen. But also we need to be able to have a way that we can package up the envelope, ship it across the network, and then unpackage the envelope that's uniform. We have to have a way that both he and I can rely on in order to make the magic happen. And the way that we do that is using the OSI model. So through data encapsulation, the application talks to the presentation, presentation talks to session, session talks to transport, transport talks to network, network talks to data link talks to physical, pushes it across the network, and then the same happens but the opposite way. So physical talks to data link talks to network, network talks to transport, transport talks to session, session talks to presentation, presentation talks to application. So hopefully that makes sense to you. And if not, then this little tidbit hopefully will make a little bit more sense to you. So why do I say that? Well, let's just say that we had this encapsulated envelope that the OSI uses. Up here, things like Outlook, or Word, or Internet Explorer are all applications. So that application uses a certain interface, a GUI, a graphical user interface, to get the data and manipulate it, and then it saves it as a particular type of file, right? So let's talk about IE, for instance, Internet Explorer. What file type typically do you see with Internet Explorer? HTML, right? Usually we see HTML, maybe ASPX, or if we got the .NET developers in here, JSP. But the application, Internet Explorer, serves it up in a way that can be presented. If we have two people that are using the same application, we can push it down the stack, send it across, let it come back up the stack, and then be presented back up to the application in a way that's uniform. So oftentimes, you know, the docx files is a presentation. The XLSX files with Excel. And I'm sorry if I'm Microsoft centric, but usually people understand that the easiest way. So things like, you know, if you have an application, you know, the Word and somebody else is using another, let's say OpenOffice on their side, they're using Linux. What do you think the system will ask you to open up that docx file in a Linux OpenOffice environment? Anybody ever use OpenOffice before? Yeah. So if you have a docx, you send it across to somebody using Linux, the first time that you see that docx file in Linux, or if it's coming back the other way, you have an OpenOffice file coming across the wire, coming up to a Word document, or if you open up Word and try to view it in Word, what is Windows going to ask you about that OpenOffice file? What application do I open it with? First time, right? Comes up with the prompt, says, hey, OpenOffice, what is that? I don't have any idea what that is. So what I'm going to do is I'm going to prompt you, what do I open this with? And then it's got a little checkbox that says, always open this file and this, you know what I'm talking about? And then from that point forward, you don't ever have to answer that again. Just automatically we'll open it up, and then everything's beautiful. So let's talk about this stuff and some of the things that come in here. So for the applications, I talk about it here. The applications, Outlook, Internet Explorer, Word, they actually will use APIs. What is an API?
Application Programming Interface.
Yeah. So that's just the way that we can talk. So, you know, one of my mentors, the way that he taught this to me is he said, "Parlez-vous français?" "Se habla español?" Come on, you guys are pretty lame. Un poquito? Okay.
Sure.
How about sprechen die Deutsch? Okay, somebody speaks it at least, right? But that's the way that we communicate with each one of these, right? So in our vast knowledge here of the OSI model, easy way to think of this is that applications talk over specific ports and protocols. And right after we get done with this domain, what we're going to do is I'm going to actually give you a pop quiz, find out how awesome you are in ports. Okay? And it's probably very similar to the one you probably remember from the security class. So SMTP, well, guess what? Simple Mail Transfer Protocol? Yeah, it uses Outlook, right? Really, Exchange uses that, but that's what it, port 25, sends it out, opens up the API, pops it out to Exchange. HTTP, well, hopefully you know that that's the way of the internet, right? Our friend Al Gore created it. Here we go. Port 80. We use the API to talk to IE. And then the printer naming, well, maybe you need to print something out over the printer, right? And if so, you need to open a Word. It needs to, behind the scenes, beacon out to the printer, and then magically you click print, and all this stuff happens behind the scenes. So hopefully that makes a little bit more sense. And as we decompose each layer, so we go from 7 to 6, what's the easy way for us to remember the OSI model? All people seem to need data processing. That's right. I've heard people say stuff about pepperoni pizza or sausage pizza, you know, whatever floats your boat. All I'm going to tell you is that that's the way I remember it. All people seem to need data processing. So if you have an interesting way to, I had somebody in in my 501 class that came up with something. She worked at a hospital and talked about doctors and I mean, yeah, whatever works for you, you know, whatever acronym you work. So the presentation layer, it works with compression and encryption, the different types of files over here for imaging, which you would imagine that it really makes sense that, you know, once it receives it, how does it put it into a format that can be utilized on the other side of where you're sending it to. So as far as the session, give me an idea of something that creates a session. What's something that creates a session?
Socket connection.
Socket connection would be right here. Yes, absolutely. Maybe SSL, right? Going over port 443, secure socket layer. That might be something that is handled the connections where you establish the connection, and then you're able to transfer data, and then eventually have that data connection released. So as we break it on down here, we get down to the transport layer. Well, when you get down into TCP, which is the transmission control protocol, you have it put into a stream, quote unquote, to be ready for pushing across the wire, because essentially the data link layer will convert the bits and bytes into electrical pulses for the physical layer. And here we're breaking it down into the stream in the TCP, the transport layer, and specifically here at layer 4 of the OSI model. Whereas the network layer, layer 3, here we'll use internet protocol, and the networking, some of the networking, if we have any CCNAs in the house or people that are networkers, maybe use the OSPF, Open Shortest Path First, or the RIP, the Routing Information Protocol, or whatever it decides to use, whatever you have set up. A lot of them by default look for the Open Shortest Path First. I mean, that just makes sense, right? Let's go and get it to where it needs to be as quickly as possible. And at the network layer, that is where it is done. A lot of times if you do things like trace route, you can actually see where the traffic's going and how it actually gets from point A to point B. So like I said about the network pushing the data to the data link layer, it converts it into bits and bytes, and we'll actually do some XOR operations and preparing you for being able to do stuff like that in the crypto domain. But once it does that, it converts it to the bits and bytes. It pushes it down to the physical layer, so then if it's wired or wireless, it can send the electrical pulses and push it across the wire for the physical layer. So any questions about the OSI model before we actually look a little bit further at each one of these domains and some of the things that are in each one of these domains, or each one of these layers? Any questions about that? All right. So the application layer, we talked about Word, Outlook, Internet Explorer. Well, what else? What else happens there? Well, while you're going through and writing in your book here and paying attention, let's go ahead and just assign some of these acronyms. If you don't already know, let's assign them actual port numbers. Okay, this might be a good exercise if it's been a while for you. I might need some help with one of them. So FTP, what is that?
File transfer.
File transfer protocol. What is the ports that are associated with that? 20 and 21. Okay? 20 and 21. Now what they won't do on the CISSP, unlike the Security Plus, is they won't say FTP is also known as ports. So CISSP won't do that. What they'll do is they'll say, Susie was communicating over port 21. And she found something, and then in the answer, you have to know what port 21 is, just to be able to get you that 50-50. So there's a bit of a difference between the lesser Security Plus, not to knock anybody who's got the Security Plus, and the CISSP, because they expect you to know all this coming in. Okay? So FTP is 20 and 21. TFTP should be an easy one to remember. That's Trivial File Transfer Protocol, and that's 69. Or some people say 69. Sorry. Have to have some fun here. So, Simple Network Management Protocol. What port is that? I'm going to need some help. Somebody's going to need help me with that. 139? Is that a guess? Somebody, will you look it up, Steve, in that book real quick while we're, I don't remember that one off the top of my head. SMTP, let's keep going. Simple Mail Transfer Protocol?
25.
25. 25. Okay, you got to know that one. Telnet? What's that?
80.
Nope, that's HTTP. So we just answered the bottom one here. HTTP is port 80. Telnet is port 23. 23. So SNMP, Simple Network Management Protocol. Somebody look that up? These fancy phones you guys got here. All right, when you remind me what that is, we'll come back to it. So those are the types of things that happen at the application layer. At the presentation layer, really it's kind of interesting. You just look at these file formats. 161, 162, 161, 162 for SNMP. Thank you. So at the presentation layer, I had somebody who was asking me probably about 7 or 8 years ago. She was like, I can't get it into a format. I can't get my document into a format that I want it to be in. Do you have any recommendations for how to reformat a document? I said, open up Notepad, pop it in Notepad, copy it from Notepad, and put it in Word. And that seems to be the easiest way to be able to have some sort of ASCII or ASCII-like, where there's no formatting. You just get rid of all the dumbness that people do with spending more time in Word, trying to figure out how to put headings in there and this and that and the other thing. Just remove it, get it into just a simple language, and then be able to copy and paste it back in. But really, what file type is it? Is the easy way to know the presentation layer. What file type is it? So as far as the session is concerned, the NFS, I'm sure that a lot of you guys are probably using file shares. So NFS, NetBIOS, the Network Basic Input-Output System. How about SQL? Anybody using SQL? Structured Query Language. And RPCs, Remote Procedure Protocols. These are all things that establish the connection where it's connection-oriented. And we'll talk about that here in a second. So it's probably TCP. Probably TCP, because it has to have a connection. All right, so at the transport layer, TCP, Transmission Control Protocol, User Datagram Protocol, UDP. SSL, it's kind of funny, SSL is here at the transport layer and not at the session layer. And we'll talk about that more whenever we get into SSL. The connection is actually established here at the session, but then the data is actually transported underlying. So we'll actually talk a little bit more about that when we get into SSL. What about SPX? What is that? We have any, I mentioned it earlier, anybody Novell? Remember Novell? Anybody using Lotus? Lotus Notes? I remember when I left NASA about 4 years ago, they were still using Lotus Notes for some things. Anytime that I see an X on the end of an acronym, I always think that's got to be Novell. And typically it is. So Sequence Packet Exchange is a way that Novell actually pushes over the transport layer packets across the wire. And it's denoted by the X here. Hold on a second. So same sort of thing here. IPX is, instead of using what everybody else in the world uses is IP, well, Novell, that's one of the reasons why they probably didn't make it, because they had a pretty good share of the market when they first came out. They use IPX. Well, really everybody else uses IP. And IP is the way of the internet, right? So we'll talk a little bit about some of the classes of IPs. Class A, Class B, Class C, and you will be expected to know that. So IP addresses are kind of like your mail address, really it lets the network know exactly where to deliver a parcel. And we talk about a little bit more in detail coming up with the different classes. ICMP, you know, some of the other exams, they want you to know a little bit more about ICMP, and but really at a cursory look, what is ICMP also known as?
Ping.
The ping, right? So if you issue a ping command, it's really doing an echo response, an echo reply, and it's got different types of pings that are in there. So ICMP is the ping. We talked about some of the routing protocols. This one's probably the OSPF is probably the most widely used. And if we got into algorithm development, we could show you why it is the most widely used, because it just makes sense. You know, you're going to take the path of least resistance to get you to where you need to be. So the data link is important here. And these two up top, the ARP and the RR, those are kind of funny names here, but what does it mean and why are they important? What is address resolution protocol? What does that mean?
One of them is MAC to IP, and the other is IP to MAC.
Okay.
And I don't remember which is which.
All right. Anybody want to take a crack at it?
I guess IP to MAC would be ARP and MAC to IP would be RARP.
So, what'd you say again?
IP to MAC would be ARP.
IP to MAC would be you have the address and you're looking for the MAC address. So yes, you have the IP address, you're looking for the MAC address. And then here you have the MAC address. For RARP, you have the MAC address, you're looking for the IP address. And you can actually issue those commands across the network, and as long as somebody's not blocking them, which usually people don't block an ARP request. Like if we were to bring up a wireless router in here, and each one of our phones, what would we, if we were to bring up Wireshark and started looking at the wireless traffic that was coming across, what do you think we would see? I mean, anybody brought up Wireshark before? You guys are looking at me like I'm crazy. I mean, I assume that you guys have looked at Wireshark before. So if we were to just bring up a simple wireless router, what we would see immediately is probably a bunch of ARPs. Hey, who has this address? Hey, who has this address? Hey, who has this address? Because it's trying to figure out, that's what it does. It's trying to figure out what is the network. Where is it? Who has what? Who's DHCPing? Who's going to connect to me? And it's quite creative, some of the things that we can do with just knowing that our devices that we have in our pockets will respond to specific broadcast messages like that. And then I just lamely put this cable closet in here. How many of you guys seen cable closets like this before? Anybody? Yeah.
I've seen, actually that's pretty nice looking.
Yeah. So, you know, we'll talk a little bit about that. All right, so let's turn off the gas pedal here for a second, because I want to take some time to ask you guys some